Good afternoon, Year 4, and here is your science lesson on Tuesday, the 2nd of March. This is lesson 2 of our States of Matter unit, and today we're going to be investigating gases and explaining their properties. We'll also start, and maybe you can finish the experiment as well. Okay, so what can you tell me about gases and what properties do they have? Hopefully you'll be able to remember some of the knowledge and the information that you learned last lesson. And if you can, hopefully you might think that you are higher on the learning pit today if you've remembered it. If you haven't, don't worry. Okay, for today then, what's the odd one out? So I've got a hot air balloon, so the gas inside the hot air balloon. I've got it's not quite steam down there, but it's coming out of the top of a building. We've got a fire extinguisher. We've got a fart. And yes, you can all laugh at that at home. We've got bubbles coming out of a fizzy drink. And we've got gas that'd be on the top of the hob. So which one do you think is the odd one out and why? Can you agree and build on ideas, even your own, and challenge them? Is there just one odd one out and why? Okay, so fizzy drink then. Today's lesson is going to be all about fizzy drinks, and we're going to be investigating gases by looking at fizzy drinks. So if you have one somewhere in your home, I'm not saying go and drink it, but if you can have a look at a fizzy bottle, that would be brilliant. And if you don't have one at the moment, do not worry, just have a look at some of the pictures on the screen. What states of matter can you identify in the materials that make up a bottle of fizzy drink? So here it is again. Which ones can you identify? So we've got the lid at the top here. What's that made out of? Plastic lid, so it's a solid. How about down here? We've got the bottle itself. Yeah, it's a plastic bottle, so again, it's solid. What about I almost said it then. What about the fizzy drink itself? And I did say it's a lemonade drink, it's a liquid. I was about to say, what about the liquid? How about the sticker on the outside of the bottle? Yeah, so the paper label is solid. And finally then I've put the arrow to one of the bubbles there. Good, and because it's a bubble, it is gas. And hopefully you're able to see those as well without saying the words. Okay, so the bubbles of gas. What are the bubbles in the fizzy drink made of? Why are there bubbles in fizzy drink? And who invented the first fizzy drink? Do you know any of those answers? I certainly didn't know who invented the first fizzy drink, but we're going to learn about it together. So we're going to watch this video to find the answers to some of these questions. And in the film, Joseph Priestley also mentioned another use for carbon dioxide, and we're going to talk about that as well. Now, I am going to play the video. I'm not going to be able to play it all though, because it's about 3.5 minutes long on the BBC, and I don't want it to not work on YouTube. So I'll start playing the first bit with you, but then I will put the link in the description for you to finish off watching it.
Who is the greatest scientific investigator of all time? Our contestants span 500 years of groundbreaking scientific discovery, but only one of them can be the winner. On today's show, trying to convince you that he's the greatest is Joseph Priestley.
Hello, Joe. You don't mind me calling you Joe?
Nay, lass. Go read ahead.
Yes, well, why don't you start by telling us about your scientific qualifications? And please keep it brief.
Well, that's easy enough, because I didn't have any scientific qualifications.
None? Who let him in? Then how can you possibly stand there and claim to be the greatest scientific investigator of all time?
Well, because I had something more important than qualifications. I had curiosity. Oh, yes. Well, I was curious about everything and anything. For example, what went on at brewery next door to my house.
Oh, yes. Liked our little drop of beer, did we, Joe?
No. What I were curious about was the way the gas floating over the beer vats fell to the ground.
You sure it was the gas that fell to the ground and not you?
Okay, I'm going to pause it there. It's quite a funny little dramatization there, and obviously that's not actually Joseph Priestley, but you need to click on that video in the link below this one on the home learning page and watch that, because again, I'm sorry, I can't play the whole video to you. Okay, so bubbles of gas. Carbon dioxide is a gas that is all around us. It makes up only 0.04% of the Earth's atmosphere, so that's way less than even 1%, but it can be very useful. Some fire extinguishers use carbon dioxide to cool flames and to stop oxygen getting to the fire. Carbon dioxide freezes at minus 78 degrees Celsius, and it becomes a solid called dry ice. It is used to transport foods that need to be kept cool and fresh, such as on aeroplanes and trains. Carbon dioxide can also be dissolved in water to create fizzy drinks. And that is how the link happens there. So, do gases weigh anything? These children are talking about the weight of gas. The girl on the left with the red circle says, gases are lighter than air, so they don't weigh anything. The boy in the middle in blue says, gas has no weight because it's invisible. And the girl in yellow on the right says, a gas does not have weight because it is a material. Who do you agree with and why? Or do you have a different idea? Have a think about that, or have a chat if you're with Mrs. Chamberlain in school. But just have a think about who you would most likely agree with, if any of them, and why. Okay, we're going to watch one more video here about gases weighing anything. And we're going to see some children thinking about this question by wondering whether the bubbles of gas in a fizzy drink affect its weight.
Which weighs more, fizzy lemonade or flat lemonade?
It's obvious. Flat lemonade weighs more. Fizzy pop's got air in it and air makes it lighter.
Okay. This glass of fizzy pop weighs 173.1 grams.
You see all those bubbles? They make it lighter.
Shake it and it'll go flat.
Careful, don't spill any.
Right, it's nearly flat now. Wait again, it'll be heavier.
172.6 grams. It weighs less now.
Why is the fizzy pop heavier than the flat pop?
It's easy to think of gases being totally light, even weightless, but gases have mass like everything else. The bubbles of gas in lemonade don't weigh much, but they do weigh something. So once the gas has escaped, the lemonade will be lighter. The gas in fizzy drinks is carbon dioxide.
These balloons are filled with a gas called helium. It's much lighter than air. But these balloons are full of carbon dioxide, which, as you can see, is a heavy gas, much heavier than air.
Okay, so hopefully that explained a little bit that gas does have weight, but we're not just going to stop there. There's no point me just telling you that the gas in fizzy drinks weighs and then it gets lighter once it's flat. So we're going to try an experiment today, and we're going to link it to our Emmett problem. So Emmett says that I want to serve the fizziest drink at my birthday party. I know that the bubbles of carbon dioxide make it fizzy, so the drink with the most carbon dioxide is likely to be the fizziest. But how do I do this test? He isn't sure then how to work out which has the most carbon dioxide. So if you look at the picture on the right-hand side, there's a Coca-Cola, a Pepsi, a 7-Up, a Schweppes, a Mountain Dew, something in the middle there, and Sprite on the end. So lots of fizzy drinks that we know of here that you might drink occasionally at home. How would you know which is the fizziest? How could we work it out? Thinking about the experiment that you did see on that video as well. If you need to pause the video to have a think about it, that's fine. If not, we're going to be learning to compare the weight of gases. So maybe we could weigh the drinks. Maybe we could measure the weight of the gas and not just the weight of the liquid. And what we'd need to do is we'd need to weigh each fizzy drink and then shake it up until it's flat and weigh it again. And then the difference between the two weights will tell you how much carbon dioxide is in each drink. So if we were to do this experiment, what equipment would we need? And I say we, lots of you are at home, so what will you need? And again, do not panic at this stage if you don't have it. You can always pause the video when we get to that stage in a moment and then come back to it at a later time. This is then your activity. So your task is to carry out that investigation. You've got Emmett's sticker on the problem on the page, and you're going to need to do a formal investigation. So again, you make your prediction, you do your variables, and then you carry on. So it says, please make sure you describe what you think will happen and why based on your understanding of the science. So before you do anything, you need to decide what fizzy drinks you'll be using and what you think will happen, and then complete your fair test and variables. So job number 1 is to almost stop here. If you have a couple of fizzy drinks, I'm not talking about testing them all, but if you have 2 or 3 at home at the moment, brilliant, then you can probably go ahead with this investigation. If not, you might have to ask parents, carers at home, the next time they go to the supermarket to please pick up a couple of little bottles. And I think bottles are easier than cans, but if you have cans, that's fine. Maybe 2 or 3 different varieties. And then you need to predict which one you think will have more carbon dioxide and why. So for example, if you had Coke, lemonade and Fanta, I predict that Coke will be fizziest. I believe this because. Or I predict that there will be more in the Fanta, and I think we'll show this by. Then we have a look at the variables, and this is what you will change, measure, and keep the same during your investigation. So even if you don't have those fizzy drinks at the moment, you can come up with 3 in your head and ask your parents very nicely when they next go shopping for their weekly shop to pick you up some, but you can still do this planning of the investigation. So it says, what will you change, measure, and keep the same? What things will you change? So we know we're going to be changing the different types of fizzy drink. So you've got your changing things as those. Then your variables. So to measure or observe, so your dependent variable. What are you going to be measuring? And just like in the video, we'll measure the weight of the gas before and the weight of the gas after you've shaken it. And we'll know that because we're measuring the liquid. We're not really measuring the gas, but by knowing the difference, we'll be able to work out what the gas weighed. So for instance, if you put your bottle of 500 milliliter Coke, you'd pop that on the scales, and yes, you could see it weighs 500 milliliters or 500 grams, it would be on your scales. You'd shake it all out and all of the fizzy gas would come out, and then you would weigh it again. And I'm telling you it's going to be lighter. Maybe you can see if you're going to prove me right or prove me wrong. Then your control variable at the end, what are you going to keep the same? Think about maybe having the same amount of liquid, all 500 milliliters, all 100 milliliters, depending how much you can have. Think about how you're going to weigh them and whether it's a fair test if you keep the same scales or a different pair of scales. Maybe think about how long you're going to be shaking it for. Is it fair to shake one for a minute and one for 10 minutes? And I have just helped you with this bottom bit, the fair test. So it says, excuse me, explain how you'll carry out a fair test. So I will use the same amount or different amounts of drink, so you can get rid of one of them. I will shake each drink for the same length or different lengths, and I will use the same or different weighing scale. So hopefully that's going to help you with that final box. Then pause the video here if you don't have the liquids at home. Okay, if you do have the liquids at home, you are very lucky to start with, and hopefully your parents won't mind if you ask if you can use them for a science experiment. You'll still be able to drink the liquid at the end, but it will obviously be a bit flatter because you're shaking the gas out of it. Once you have them, then you're going to carry out your investigation, and you're going to make sure you follow your fair test criteria, and then you can use the results table. So you're going to have name of drink. You're going to have to weigh it when it's fizzy. So as soon as you buy it from the shop, and when it's at home, when you haven't shaken it around, you're going to weigh it. And then you're going to weigh it again here when it's flat. So I haven't included on the results table how long you're shaking it for, but obviously between those two, you need to shake that fizzy drink. And then you need the weight of the carbon dioxide. And this is going to be the difference between the two weights. So if the weight was 500 grams, when it's fizzy, and I'm telling you that it's going to go down to 495 grams, again, you're going to have to prove me wrong. When it's flat, the difference, or the weight of that carbon dioxide, the difference is 5 grams. So that just shows you how you can fill it out. Now, obviously, you've not seen me do the experiment. I've just made up those numbers. It might not be those ones at all. Then finally, can you use your results to complete your investigation and to give the results and explain how you know? So looking at your conclusion, look at the results. Which of the drinks was the fizziest? So you're going to know that by the final column of the weight of the carbon dioxide. There was more fizz in it. Was your prediction correct? And which drink should Emmett serve to his friends? So you can use those sentence starters if you'd like to. My investigation showed that, therefore my prediction was, and then based on my result, I would recommend Emmett serve ... You could do this over 2 lessons or over different days if you need to. Again, hopefully we'll be back at school very, very soon. And don't worry if you can't do this. Hopefully we'll be able to have a go and look at some of these gases at school anyway. If you have got to this stage, a huge well done. I'm not going to ask you to pause again for the learning pit, but maybe have a think about what scientific skill that you've used to do this experiment, if you've been able to complete it, and then where you are on the learning pit. What did you learn from that experiment using those fizzy drinks? A huge well done for having a go at that if you were able to do it at home. And I will see you soon for some more science. Bye for now.